Hey Vamsi. This line simply sets the stage, introducing the topic of optimizing the MeanShift algorithm's parameters. It's like the title of our investigation, setting the context for what's to come. Here's the core question. Vamsi, we need to figure out which parameter tweaks will make the MeanShift algorithm run faster. It's a multiple choice question, so we need to carefully consider each option. This option suggests increasing the bandwidth parameter. Remember, bandwidth defines the neighborhood size the algorithm considers. Increasing it means it'll look at more data points, making each step slower. This option proposes to decrease the bandwidth. A smaller bandwidth means the algorithm examines fewer data points per step, resulting in faster calculations. Bin_seeding. This is a clever optimization technique. Setting it to true or increasing it, if you interpret the question that way, activates this technique, which involves dividing the data into bins before processing. This reduces the computational load, making it faster. Runtime impact. Generally, using bin seeding, TRUE, speeds things up. It's like having a shortcut. The algorithm looks at smaller groups of data points first to find potential cluster centers, instead of checking every single point. This reduces the amount of work it needs to do, making it faster. This row describes how using or not using bin seeding affects the algorithm's runtime. In a nutshell, enabling bin seeding generally makes the MeanShift algorithm run more efficiently. Smaller bandwidth means MeanShift considers a smaller neighborhood around each data point when calculating density. This is like searching for a specific person in a smaller, more manageable group compared to a huge crowd. Calculating density in smaller groups takes less time, thus reducing computation time. The max_iter parameter sets the maximum number of iterations MeanShift runs. Think of each iteration as one step in a journey. Reducing max_iter is like shortening the journey. Fewer steps means less computation time, even if the algorithm might not fully converge to the optimal solution. The bin_seeding parameter uses a smart technique to reduce the number of starting points for MeanShift. Imagine searching for clusters in a huge field. Instead of checking every single blade of grass, representing a data point, bin seeding divides the field into bins and only checks a few representative points from each bin. This significantly speeds up the process. Hey Vamsi, decreasing the maxiter parameter directly reduces the runtime. Think of it like this. Maxiter sets a limit on the number of times the algorithm iterates through the data. Fewer iterations mean less computation time, even if the algorithm may not find the absolute best clustering solution. It's a trade-off between speed and perfect accuracy. Hey Vamsi, decreasing the maxiter parameter directly reduces the runtime. Think of it like this. Maxiter sets a limit on the number of times the algorithm iterates through the data. Fewer iterations mean less computation time, even if the algorithm may not find the absolute best clustering solution. It's a trade-off between speed and perfect accuracy. Using bin seeding significantly speeds things up. Imagine you're searching for a specific item in a huge warehouse. Bin seeding is like dividing the warehouse into sections first. Instead of checking every single item, you start by searching the most likely section. That makes the whole process much faster. Using bin seeding significantly speeds things up. Imagine you're searching for a specific item in a huge warehouse. Bin seeding is like dividing the warehouse into sections first. Instead of checking every single item, you start by searching the most likely section. That makes the whole process much faster. Let's talk about the bandwidth parameter. A smaller bandwidth means the algorithm looks at smaller neighborhoods of data points. Think of it like having a smaller search radius. The smaller radius means fewer calculations for each point. Therefore, reducing the bandwidth leads to a faster runtime. Let's talk about the bandwidth parameter. A smaller bandwidth means the algorithm looks at smaller neighborhoods of data points. Think of it like having a smaller search radius. The smaller radius means fewer calculations for each point. Therefore, reducing the bandwidth leads to a faster runtime. This is the title, setting the stage for a discussion on optimizing the MeanShift clustering algorithm parameters. It's all about making the algorithm run faster without sacrificing too much accuracy. This is the core quiz question. We need to determine which parameter changes will improve the speed of the MeanShift algorithm. This is all about understanding how the algorithm's settings directly affect its performance. Increasing the bandwidth makes the algorithm look at a larger area around each data point when grouping. That means more calculations, making it slower. Think of it like searching a bigger haystack. It takes longer. The opposite, a smaller bandwidth, means focusing on smaller regions, requiring fewer calculations per point. Less work equals faster results. Bin seeding is a clever optimization. Think of it as pre-sorting your data into bins before clustering. This reduces the number of starting points, significantly speeding up the process. Switching this to true activates this optimization and speeds things up. Max_iter simply limits the number of iterations. Reducing it means the algorithm stops sooner, less work, faster completion, but possibly a less precise result. A trade-off between speed and accuracy. This column highlights the parameter adjustments that would directly speed up the MeanShift algorithm. It's a summary of the options that reduce the runtime. This column captures the parameter adjustments that would make the MeanShift algorithm run slower. This simply labels the column describing the changes that are applied to the algorithm's parameters. This column describes how the different parameter adjustments impact the algorithm's runtime.